Problem solving is one of the most important skills we teach in math classrooms. But even though we know just how valuable it is, developing students' problem solving skills can be challenging. Today, I'm sitting down with Robert Kaplinsky, co founder of the Open Middle website and author of Open Middle Math Problems That Unlock Student Thinking. He's also the founder and president of Grassroots workshops and an incredible keynote speaker to educators around the world. In this interview, we talk about everything from getting started with problem-based lessons to supporting students who appear unengaged or unwilling to give problems a try. We also talk about how to approach our own professional growth in a way that is achievable rather than overwhelming. Let's get to the interview. Robert, thank you so much for coming to the show. I'm so excited to get to chat with you today.
I'm really grateful for this opportunity. Thank you.
You are somebody that I have just respected and loved your work for such a long time. And so it is so cool to get to talk to you in this setting. I know that we have just developed our math friendship. I always love learning from you. I love your perspective on things. And so I think the teachers that are watching this are going to find a lot of value in our discussion today.
I'm super flattered. I feel similarly.
I thought we would kick it off by I'd love to just hear you share a little bit about your math story and just how that impacts the work that you do today.
I've thought about this a lot because it's a really weird situation where I realized that. So I graduated from UCLA with a degree in math. So on paper, I know a lot. But the one constant has been that the more math I learned, the more convinced I am that I know nothing about mathematics. And it's a really weird set of emotions because there's this thing called the Dunning-Kruger effect where the more that you know, the more you realize you don't actually know something. But there's at the beginning where you actually think you're like an expert on something. And that's the way I felt early on. And you start to have these moments where I remember I was doing professional development early on where they asked me, why do we invert and multiply when you do fraction division? And in this period, I went through the 5 stages of grief. The first stage was denial. If I made it this far, obviously don't need to know that. And then you have all these other parts where you're trying to process this, where you're like, wait, is there an actual reason for this? And if there is, what does that mean if I don't actually know it? How well am I able to teach that to my students? And the reality is that I've had this experience with virtually everything. Subtraction, are you really borrowing a 10, or what does that mean? Or bringing down a 0 when you multiply? And I don't care what grade level of mathematics it is. I had this identity built around I was the best at math, and trying to reconcile that with what my experiences have been has been really challenging. What I've come to actually believe, whether this is true or not, I'm choosing to believe this, is that my struggles with math are actually my superpower, because if I didn't have that, then basically any way that we're teaching math is going to be satisfactory. But I know that that didn't work for me. So I try to find other ways that might work for people in general. So yeah, I struggle with math. It's weird, right? On paper, if I graduated with a degree in math, I did well. But I felt like an imposter the entire time. I don't actually know what I'm doing, but somehow I'm passing these classes. I was a really good math robot who could repeat these steps and simultaneously have no idea what I was doing. So that's my story. But again, I've come to believe that helps me have more perspective for why it's so important to deeply understand what you're doing.
Yeah, so I love what you said about your struggle in math became your superpower. And it's funny because we have similar stories in the sense that I was very much like a math robot. I would have said that I was strong at math, and I don't think I really struggled with math until I became a math teacher. And I was like, oh, if I can't teach this, do I truly understand this in an in-depth way?
Absolutely. I remember I was teaching something about circles. Maybe it was circumference or area. And a student asked me where pi came from. And I responded with, it's just a number that has to do with circles. Because I had no freaking clue that there actually was a reason for pi. And the reality, what I think is really important to realize, is that the reason we did it that way is because no one ever taught it to us. And the reason that no one ever taught it to us is because no one ever taught it to them. And it's this vicious cycle that is really hard to break out of, where you know things and you don't know why you know them. But unless you go out and seek that knowledge or find a different way to do it, that cycle will just continue.
Yeah, absolutely. And it's very much like you don't know what you don't know, or you just continue on in teaching the same way you were taught. And now that there's this expectation that we are supposed to teach for understanding, that's really hard to do when you don't have that understanding yourself. And so I love the work that you're doing in the professional development world, and really empowering teachers with that knowledge and with the pedagogy to be able to teach in a way that is really probably different than the majority of us were taught.
I appreciate that. I don't know if I've done enough to earn that statement, but I will say this. I think that one of the challenges with social media and just living in today's world is that people share all the pretty parts, but not the struggles. And it can leave you with this false image that you're the only one who struggles, which is freaking BS because everyone is struggling. And the only one who's not struggling is a liar. Like they're just either completely ignorant of the things that they don't know or not ready to admit that to themselves. So everyone's struggling. I mean, like I said, I was a math major. I've never taken a statistics class in my life. So there's a lot of stats I don't know. There's so many things I still don't know very well. And I think that's really a theme of life, right? The more you learn about anything, food, culture, you're going to realize there's just so much more than you could ever possibly learn. So, yeah, if you're struggling, then join the club.
Yeah, and I appreciate the fact that you are just like that is front and center. And yes, the more you said at the very beginning, it was like the more you learn, the more you realize like you don't know. And so
Absolutely.
there I think one of the first places that, or like one of the first resources of yours that I was exposed to was your open middle problems. And on the open middle site, like when you open it up, the very first thing that it says is challenging problems worth solving. And I think that thinking back to like my own education, I did a lot of problems that were not worth solving, looking back on it. And so I would love to hear from you. What does that even mean to have a problem that is worth solving?
First off, yeah, we've really struggled to think about how to articulate succinctly what is an open middle problem. And I'll give you an example in a second. But I think that everyone will relate with what you're talking about. Um, what happens to those kids who get done early or are appearing to understand things, right? Typically, it's either do we give them more worksheets or do we move on to the next topic? And that starts a really bad cycle because even if they start working ahead, are they just going to repeat the same things when they get to the next class? Like, this is not a really satisfying thing. At the same time, we have to realize that there are students who appear to know what they're doing, and later we find out they don't really know as much. So how do we get that really figured out? So I'll give you an example that maybe it's easy to communicate without a visual. So here's a problem somewhere in the fourth, fifth grade range. Just think of a picture that has two boxes as a numerator and two boxes as a denominator. So it's a two-digit number over a two-digit number. Now you can place a digit in each box using the digits 1 through 9, and you can't repeat a digit. And I would like you to think about making a fraction that is as close to 1 as possible. So like if you just start off and you think, 1, 2 over 3, 4, you've now made 12 over 34. Is that the closest fraction that you could make to 1? And it's not the price is right, so you can go a little bit over or under, but you start to get this exploration of like, I mean, one option legitimately is like pick numbers out of a bag four at a time and just place them and see what happens. And you could be like amazing at figuring out how close something is, but that's going to take a while. Even if you have a calculator, it's going to take a while. So it starts to force you to think conceptually, like, oh crap, if I don't want to pick these numbers randomly, like what numbers do I want to pick? And you get different strategies starting to emerge. This understanding that probably the value of the numerator and the value of the denominator probably want to be close together because
Right.
that usually means it's closer to 1. And you start to think, well, if I have a larger value for the denominator, the pieces are going to be smaller. So the missing quantity is going to be smaller. And now you're trying to think about how to reconcile this. And so this is a challenging problem that actually feels worth solving. You can start to see that if this was done with a class, you kind of have these fights that go on where kids are like, no, mine's closer, no, mine is closer. And then how do you know? And you could find this whole classroom just diving into this one problem, spending the whole period fighting using mathematics as their language. So we have hundreds of these problems from kindergarten through calculus. And I just love these because the reality is a kid could rock a whole worksheet of comparing fraction problems and get obliterated by this one. So if the
Yeah.
worksheet's not really giving us the information that we want, if it's not challenging, if it's not satisfying, bluntly, why the hell are we using them as much as we are? And I think the answer is because we're not given many better alternatives, and that's the way we were taught. So we're just doing the same thing. So yeah, I love this stuff. I'm passionate about it, as you can kind of tell.
Yeah, and no, I love that. I love what you said. You said they're communicating with mathematics as their language, and that's exactly what they're doing, and it's exactly what we want, and it's a very motivating problem. Even as you were describing it, I was like, "Okay, how would I approach this?" So, okay, so that's one type of problem worth solving. Another like component of what you do that I even used in my own classroom, where you're like real world problems that you have, or your tasks. Those I would say are also very much problems worth solving. And they take kind of a, maybe not like a different approach, but we have the lens of that real world aspect. And where do we see math outside the classroom? And I know for me, I use those. I had a very much like a problem based lesson structure. That's just how I approached teaching. And I know that that's one that you talk a lot about. I would love to hear from you, like what makes a problem lesson or problem based lesson a problem based lesson, and how is that different than like a traditional style of teaching, maybe how we were taught growing up?
Yeah, there's a lot to unpack, and then I'll try to give a satisfying answer to that. So let's start with one thing that I think is really important to realize. I'm going to say the quiet part out loud right here. The vast majority of what we teach our students in K-12 mathematics, no one's ever going to use again. And just think about what the hell that just, all that in there, right? If we're teaching things that no one's going to ever use again, like what does that mean about anything we're doing? Like when's the last time any of you ever multiplied decimals by hand? Like that just doesn't happen. Yet we spend all these weeks on multiplying and dividing decimals. Why? Adding decimal, I mean, all this stuff. There's just so much. And so it begs the question, like, if we are doing that, why? And if we're supposed to be not doing that, what should we be doing? And I think that the reality that we all have to consider is this: regardless of where you live, every place basically has the same purpose when they describe why are we learning anything. And it's really college and career readiness. The reality is that the skills you need to be ready for whatever it is these days is vastly different than it was, let's say, 50 years ago, let alone 20 years ago.
Mhm.
But if the skills that we're teaching now are basically the same as they were 50, 60 years ago, then it's a lie. Because in theory, what we should teach should change as the skills you actually need change. 50, 60 years ago, maybe calculators weren't, I guess actually maybe longer than that. I'm feeling kind of old right now. But there was a time where calculators weren't everywhere and you needed these skills, but that's not the time now. So again, it comes back to this question of what should the purpose of mathematics be if it's not just teaching kids to be robots and computation, because that's not no longer the thing that we need. And what I keep coming back to is problem solving. I mean, maybe there's going to be a time where ChatGPT can actually do that part too, but right now we're still at a place where it's not so important to do the computation, but knowing what to put in the calculator is still critically important.
Yeah.
And the reality is that there are two kind of components that I see in problem solving. And I use this model of spies and analysts. Breaking it down without going too deep into the metaphor, one part of that is figuring out what information do we actually need. Like if I was going to say, how much pizza do we need to order? Well, that's a pretty good problem. And then we also have one like you might see in a textbook. There are 15 people at a party. Each person eats 3 slices of pizza. Each pizza has 8 slices in it. How many pizzas do we need to order? Both the first phrase and the second have that same essential, how many pizzas do we need to order? What I think is important to realize is that in real life, no one ever tells you how many people are coming to the perfect tea and how many slices each person are going to eat and how many slices are in the pizza. I mean, everyone in life has ordered either far too many pizzas where you're eating pizza for a week, or you got to go and buy more pizza because you didn't get nearly enough. Because the reality in real life, you don't know that all that information. That's what the spy component is what information do you even need to figure this out? And I think that students struggle with this because textbooks, by the nature of being pre-printed, basically say, here's everything you're going to need to know. Maybe they're throwing a piece of information you don't really need, but by and large, that's a skill that's really underdeveloped. The second skill, and if you think about, like, for example, how much money do I need to save for retirement? What information do you even need to know? Like, and some of that information you don't even know how to find. And that takes us to the second part, which is this analyst part, which is after you spied and acquired the information, what do you do with that? Like, how do you take that information and do something with it? Do you, going back to the pizza, do you consider that maybe there's 8 slices of pizza, but a slice of a small pizza and a slice of a large pizza or extra large pizza, maybe it's not the same amount of pizza? Or do you include coupons? Or do you include delivery fees? In real life, there are a lot of different variables, and we don't have a lot of practice with that. So this is perhaps a long-winded way to explain that I'm really interested in these real-world problems that just present a scenario without a lot of text and just say, like, which one do you want? For example, there's one I love from Andrew Siddell, who runs Estimation 180, where he's got this giant rectangular prism file cabinet and he starts putting post-it notes on it. There's no text. It's just the question. He just does that. And students are wondering, how many post-it notes are going to cover that? I've got an image of actually perfect for around fifth grade of a large pile of drug money, which sounds a little bit risque, but it's just a giant pile of stacked money. And if you show it to kids, they're like, what is that? How much money is that? Like, can I have that? And the vast majority of those questions can be answered using mathematics. So you just prevent this scenario and kids have to start figuring out, like, what do I know? What do I need to know? How am I going to approach this? Which problem solving strategy might work? And so I really like the simplicity of finding an engaging, intriguing scenario that kids can really explore. That's not where you're telling them what to do, but more they have to figure out what are the skills that they need and the strategies they need to implement to figure it out.
Yeah. So I was smiling because I've used that exact problem with my students in fifth grade, the drug money one, and immediately they are hooked. So I love that. And a lot of what you said, talking about what we are currently teaching and that a lot of it students don't need, or will not need, or at least in the way that it's being taught. And this is something that I've talked to a lot of teachers about because I know for me, when I was teaching in fifth grade, there's a standard about creating hierarchies of shapes. And I was like, why are we teaching this? This is ridiculous. This is a waste of time. But what I got to is it actually is a way of thinking that students need in real life to be able to say, what is it like? A square is always a rectangle, but a rectangle is not always a square. And that seems so silly. Like, why are we really focusing on this? But there are times, and of course, I'm like sitting here trying to think of a specific example, but even just I don't know, I can't think of a good example off the top of my head, but it is a way of thinking that students need. And it's like, I think when we as teachers really sit back and look at, okay, yes, these are my standards, but what is the thinking or what is the, I, you wouldn't consider problem solving like a soft skill. That's not a soft skill, but whatever type of skill you would call that. Like what,
Mathematical modeling.
yeah, like how can I develop that skill or that experience that students will need through this specific standard? I think that's a more productive way to approach, the standards that we are required to teach.
Yeah. So to be clear, it's not my intention to say that the math that we're not going to use has no value. What I am trying to acknowledge is here's the reality. There are far more standards to teach in 1 year than you have time to teach in 1 year.
Hmm.
So, I mean, let's be real. Like, there are almost no teachers who are teaching all their standards in 1 year. Typically, it's whatever's at the end of the textbook or at the end of your curriculum guide or pacing plan. You just don't teach because you didn't get time to it. Typically, it's like your geometry or measurement and statistics standards. They just don't get taught, and that's a pretty bad strategy to just cut the end. Because you're not necessarily ordering them from most important to least important. So the reality is that it's unfortunately teachers are given far more standards to teach than they possibly could teach in the year. If we're looking at all the things we could teach and we're trying to figure out how to make time for all of it, maybe we prioritize the things that kids will absolutely be using, and then the things that are helpful and beautiful and nice to have come a little bit later on. Because there's beauty in all kinds of math. But I think that the reality is that so much of what you actually need in life, we don't have enough time for. And so problem solving often gets skipped. I know because I did it the same way when I was in the classroom.
Yeah. I just had a conversation with Julie Dixon, and she said a lot of the same things that you're saying in the sense that the expectation for the amount of standards, we're supposed to teach every single standard, wildly in-depth level in a single year. And it's just not realistic. And so I love that you really mirrored a lot of what she said in our discussion of we've got to focus on, okay, what are the like priority concepts and what are the things that if I'm hearing you correctly, it's like, what are the things that they are going to use in life beyond the classroom? These are the things that we really need to lean into and focus on.
I mean, what I really think is that standard writers have let us down and that they need to own up and not make it the teacher's job to figure out what to cut. They really need to give us a set of standards that's actually something that can be done in a school year.
Yeah.
And that happens, and you just teach the standards and everyone's happy. But until then, I did a survey actually. I surveyed 383 math teachers and asked them, do you have enough time to teach 1 year of standards in 1 year? 83% of them said they do not. Of the 17% that did, which shocked me to be honest, many of them said that they taught like 80 to 90 minutes of math a day. Well, if I had 80 to 90 minutes of math a day, I could do it too then. So if we agree with that then, and we agree that we're cutting, just it's an impossible situation. And if you got to prioritize something, I'd prioritize teaching math through problem solving.
Yeah, I love that. I'd love to hear from you. Just what would you tell the teacher who, a lot of us grew up in school in a more like traditional style classroom where it's very much like focused on the algorithms and I'm going to show you how to do this and then you copy it and we'll practice it and then you'll get it and we'll move on to the next thing. And so do you have anything to share for the teacher who maybe has been teaching in that way and wants to explore teaching math through problem solving, but that feels kind of big and scary and unfamiliar? Like, how do you get started with that?
First off, I would just say give yourself grace. Like being a teacher is like darn near impossible sometimes. It's a really challenging thing to do where you have to be an expert in so many different things with not nearly enough money, not nearly enough time, not nearly enough support or resources. So be kind to yourself and give yourself grace because there's a lot of messaging about what we're not good enough about and not enough about we are good enough. So
Yeah.
first off, there's that. Realize that if someone had actually taught you this way, it'd be a hell of a lot easier. Realize that we are going through a time where like students are struggling. Just let's be real. Mental health issues for everyone in society is hard. It's a very, very hard time to be a teacher. So I just want to put that out there that there are a lot of reasons why this is challenging. And another one is I wrote this blog post called I Hope You Are Embarrassed, which is a really weird thing to write to teachers. And I want to unpack this because I think it's a really important way of thinking about things. When I look back at my first years of teaching, like I'm mortified. Like I would absolutely fire myself if I was the administrator of myself. I love my kids. I was doing the best I could, but I didn't know what the hell I was doing yet. And I didn't do a great job. But when I look back and I realize that I'm embarrassed, like that's a great thing. Like, you know what the worst thing would be? Is if I'm not embarrassed at all because that's still the way I'm teaching right now. So when you look back and embarrassed, the weird part about it is that it must mean that you have grown since when you were doing the thing that you're embarrassed by. So actually, like, I hope that you're embarrassed as often as possible because that absolutely means growth. Now, it still is a weird set of emotions to reconcile this proudness of growth, but also the embarrassment of where you were. But if you're bringing your best version of yourself every single time, what else did you have to give? Like that was the best you could do. And now you can do better. So fantastic. So again, if you're looking back like, oh my God, I can't believe I didn't do this. Yeah, join the freaking club. Like that's my entire life is looking, whether it's parenting or marriage or whatever. I'm trying the best I can, but I keep looking back and wondering like how I didn't do better. With all that being said, there are a lot of different ways you could go about it. If you go to my website, robertkaplinsky.com, I have real world problems that are all free for you to try out. Find one that you like. For example, some contexts are more fun than others. Like if you're a fifth grade teacher, that drug money problem, that picture by itself, the kids will riot if you show them that picture and then be like, yeah, we don't have time for this. Some contexts are so engaging that they want to do it. There was a mother duck that had something like 60 or 70 little ducklings. It's a great one for kindergarten and first grade counting. Like whatever grade level you teach, there is something for you. If you're secondary, I've got ones where there are linear functions and I've got everything. But I would just pick something and try it out yourself. Like, do you enjoy it? Once you've done it, I would think about one of my favorite ways of implementing this is thinking about the 5 practices for orchestrating mathematical discussions. So the anticipation phase is really important. Thinking about all the correct ways kids might solve it and all the ways they're going to get stuck. Because I've never taught a lesson where every kid got it right on the first try. And so when you know how they might get stuck, you have a better idea of what you can do to help them get unstuck. And just starting there. Steve Lyon shares this quote, which I think is really good for helping us stay grounded. The goal should be 10% improvement a year. Too much less than that, and I don't know if you're growing enough, but too much more than that, like reinventing everything every year, you're going to burn out and leave the profession. So 10%, what is that? Like a new lesson, one lesson out of every 10 is new. I think that's a pretty, that might be like 1 to 2 new lessons a month. That's, I think, a pretty good place to start because then the next year, you've got more and more. And by 3 years, you've got a pretty good chunk of new lessons. I would go take a free lesson and go from there. I have an online workshop called Empowered Problem Solving that you can take to if you'd like more experience. But honestly, it's just like don't take a brand new cooking class if you've never even tried to cook the thing. Try to cook it, see what goes well, see where you want to struggle, and then from there you can have an idea of whether you need if this is your jam and if you want professional development on this topic.
Yeah, I really appreciate what you said in the sense that I think a lot of times when we see something new or we want to try it. I know for myself I struggle with this like all or nothing mindset of okay, we're just going to jump right in and that's exactly what we're going to do. We're not going to do anything else. And so I love that you gave teachers permission to say, like, just try one, see how that goes. It's not that this, okay, you hear this and you're like teaching through in problem solving is best or is a way that's, can be really successful for students learning. Now I need to completely change everything I've done and move in this direction. So I love that you said, like, try a problem, see how that goes.
I would definitely also recommend don't make the problem. Find the problem that's already made, try it out. If you love it, use it. Like spend your time trying to get good at implementing it, not on making them. My first problems are terrible. Like don't scroll all the way to the bottom of my problem list. The first ones are terrible. I thought my heart was in it, but again, I'm embarrassed by little things. Like the very first problem I made was on uh, there was like bulk peanuts for like I make up a number $3.29 a pound, or like a prepackaged bag of like $2 and something for 20 ounces. My numbers are off, and I asked kids which deal is better, and we did it with kids, and it was terrible. And what I came to realize afterwards is kids don't freaking care about buying peanuts. So like the drug money picture is like a different level of engagement than buying peanuts. And my point is just you want to pick a problem that you know is fun because when it messes up, you don't want to be like, was it the context or was it my delivery? When you know it's a fun problem, then you can realize, okay, it's some other structure, and you can focus more on getting good at implementing it.
Yeah, that's really good advice. So I won't be scrolling all the way back to your original problems, but I have done quite a few of your problems and I can attest that they are fantastic. They are highly engaging. And yeah, I mean, I know that as I was talking to teachers just the other day about teaching in a problem based lesson or teaching through a problem based lesson, is one of the concerns that some of our teachers were talking about was I struggle to even get my kids to try as it is. And so I feel a little anxious, going this route and trying this problem-based lesson when I can't even get them to try on the simple things. What are your thoughts around, working with students, motivating them to jump into the problem and like give it a try?
There's a framework that I have found useful, and it's this question: is the issue that you're experiencing a will issue or a skill issue? And let me unpack that for you. So, will issues are like the will, desire to do it. And it could be anything. Will issues could be they are unhoused, they did not eat breakfast, they did not get sleep, their parents are going through divorce, they just got dumped by their person they like. There's someone in the classroom who will make fun of them if they say anything. Their clothes have holes in them, like a bajillion different things. Now, if it's a will issue, the solution is not let me show you again how to add fractions, right? Because that's not the issue that's at the core here. It could be self-esteem. Tons of will issues that come up with this will be things like a lot of kids have an identity built around I'm great at math, but the real identity is I'm a really good robot who can follow the steps in my notes and do it really quickly. And then these problem-based lessons are like the opposite of that. There are no notes on what to do, and you're not supposed to get it done. Well, I mean, that's not the goal to get it done quickly. So then these kids could be having like elementary versions of existential crises where they're like, am I good at math or am I bad at math or whatever? So sometimes it's just all they need is like a pep talk. Guys, like, I want you to know something. I did this problem and I struggled. I'm the teacher. I'm doing a problem with you that I also struggled and it was not easy for me. So if you struggle, join the club because that makes you perfectly normal, right? If kids unhoused, like that's a completely different category of issue than like the mathematics. So I think that's the first question. Is it a will issue? Then, once we've kind of like substantially addressed the will issues, we can talk about skill issues. Those could be things like, I mean, let's be real. Cubes is a very commonly used strategy for solving problems in context, word problems. Cubes works extremely well for like this many problems and completely falls apart for everything else. And you know how I know about cubes is because I freaking use something just like it. So I'm not trying to be like, you all suck and I've always known. Like, I did that too. But what I came to realize is like, this is a really fake way of approaching problem solving. And when you realize if you take that crutch away, it's like, what the hell am I supposed to do with these kids? So I have on my website a free resource called the Problem Solving Framework. And if you're looking to get started, that might be useful for you. So it's a, well, if I'm not going to use cubes, well, what should I be using? That's what this is. So, like the very first section is, what problem are we trying to solve? Now, I don't care who you are in the class. You can, I mean, if you can write words, then you can put something in this box. And so it's a very low entry point. The next question is, what's an estimate? What's your best estimate? And it's like Goldilocks here. What's a number that's no way it's lower than this, no way it's higher than this, and your best estimate's in the middle. So for number of ducks, it might be like, there's no way it's less than 15 ducks. There's no way it's more than 200 ducks. My best estimate's like 50 ducks. The next two sections are, what do you already know and what do you need to know? And this is really good to do after the estimate because kids would be like, well, how am I supposed to give you an estimate? I don't know this and this and this. Like, I need a picture, or I need to know how many ducks typically have, or I need to know what are the dimensions of this pile of money, or I need to know what kinds of bills they were. And asking them for what for an estimate makes you really aware of, well, how am I supposed to, like, if I asked you how much money do you need for retirement, it would trigger you to think about all the things you know and that you need to know, like how much money do people typically need, and how many years am I going to live, or whatever these things. So you start to develop these skills, and then from there you give them information, you review the information that they have, you share information that they ask for, and then they try to solve it. And you start these cycles of realizing, oh wait, I forgot to ask about this. That has been really useful. So just to recap, you're examining the will issue. Sometimes it's like a little conversation, just like, I got you, and I understand it's a struggle, but I believe in you. Sometimes then it's a skill issue. A really surprisingly useful question that's in between will and skill is, when kids are stuck and they don't know what to do, you ask them, if you knew what to do, what would you do? Because sometimes it's not that they don't know what to do, but that they're afraid of going down this rabbit hole and getting it wrong, so they're stuck. So they might say generally, I have no freaking clue. That's why I'm asking you. I mean, not quite in those words, but they might say, well, I was thinking about adding these together, but I'm not sure if that'll work. And you'd be like, yeah, that's a great idea. Try it out. So it's super complex that actually in my workshop, I've got this one module with 14 of the most common ways people get stuck, and a whole module on how do you prepare for and facilitate these lessons that go into that. But if you struggle, join the club. These are the parts that are really important for us to deal with, because that's a skill that we really need when we grow up.
Yeah, so I really like that will, is it a will issue or the skill issue? And kind of in between there where you were talking about if you knew what to do, what would you do? And students being afraid to get started. That was something when you came and presented at the math experience and you did your session and you showed the open middle worksheet, which I've used open middle problems, but I don't think I ever recognized that there was a worksheet there. I absolutely loved that. It's something so simple, but on the worksheet, you have like attempt one, attempt two, attempt three. And I think it just normalizes that, like, hey, you're not going to get this right on the first time. It's okay to try something. And you'll likely be wrong the first time. And you can keep going and have that second and third and fourth attempt. And so I think even just that simple worksheet right there, um, I can see how that can be really powerful and kind of combating that like middle ground of like, oh, I'm afraid to even try something. What if it's not right?
I think what's important to realize is that you have the vast majority of the skills you need to do these lessons, but there are some slight tweaks that will make it better. You know how I know about these tweaks is because I screwed up in 50 times of doing these lessons and trying to figure out, well, what could I do better? So, yeah, join the club. But I want you just to realize that doing these lessons are not going to harm your students. Like, the worst thing that's going to happen is still probably going to be better than the word problem that you pull out of the textbook. So, and every single time, I mean, so I think personally, elementary teachers have the hardest job in education. And I just want to contrast it to being a middle school teacher when I was in the classroom. Like, I would have the class 3 or 4 times. Well, first period might suck, but by fourth period, I was a freaking expert because I worked out all the kinks here. And I think that that's a really important thing to realize, is that the more you do this, it could be, awkward at times, but you do get better. And if you want to get better more quickly, then there's professional development options available, whether it's mine or a number of others.
Yeah, and I love that you're kind of like shifting into talking about professional development, because one thing that I have heard from you, I think several times, that I really appreciate, and I've kind of even like brought that into my own language and my own mindset, is you said, I don't want to be right, I want to get it right. And I think with that, it's a humility in saying, I'm not so stuck in where I'm currently at in my own knowledge that I'm not open to learning and growing. I think that's so important, really, just as humans, but then also in just our journeys as math educators. And so I'd love to hear from you before we kind of like dive into just the professional development side of our growth journeys. Is what's something that you used to believe to be true about math education that you have changed your beliefs on? Could be anything, big or small.
Well, I know I used to believe that it didn't really matter why something worked as long as you get the answer. And I think I started to really dismantle this when Common Core came out because they talked about that they wanted students to have a rigorous understanding, and that rigorous was made up of three components: procedural skill and fluency, conceptual understanding, and the ability to apply mathematics. Now, you can choose for yourself how you want to define rigor, but I think in general, I mean, it's not unreasonable to think that kids can do whatever the skill is quickly and understand how it works, that they understand why it works, and that they can apply it. When I started to use that framework to look at the things I know in mathematics, I had like not quite a panic attack, but this realization of like, oh crap, like I don't think I have these three things for the vast majority of math education. And it made me just kind of this cognitive dissonance. How do I hold the belief that I'm good enough with my just doing it quickly with the reality that you kind of probably need to know how some of this works and I don't? And so, really, just unpacking these beliefs, I've come to realize that there should be very few things that you hold on to, and nothing can make you change your mind. Because, in general, I think a safer place to be is this is what I currently believe, but I reserve the right to change my opinion if I see more information. And if I can give you a compliment, you can never surround yourself with too many people who will tell you what you need to hear. The worst thing you could be in is a situation where you're surrounded by people who just like tell you what they think you want to hear. And so, like, just every time I talk to you, I learn so much more because you have such a great perspective and so much experience. And so, I just think it's really important to cherish people like that in your life because you might find out that you actually have very few people who, I mean, also, it means that someone thinks that you're worth the time to spend that energy helping you understand that. So if you have people like that, cherish them and tell them that you appreciate them because they're really trying to help you be a better version of yourself. Now, I have to remember to tell it to my wife and live this, but for the most part, yes, I love when people tell me how to do things better.
So, and I, I this is really truly just something I really appreciate about you. It's I think in math education, and I wonder if it's just like the type of personality that typically becomes like a teacher or a math teacher. It's refreshing how loosely you hold your beliefs really about anything. And I think you're just so flexible and willing to continue to learn and grow and are open to so many different perspectives and opinions and all of that. Is that something that has just it's always been how you are, or did you really have to like grow into that? And the reason I ask that is because it can feel uncomfortable when we believe something about math, come up against this thing that makes us feel like, oh no, I know how to do this. This is wrong. And so, how did you get to this place of just having that like humility to say, like, I don't know everything. Like, I thought I believed this, but now I must be wrong.
I appreciate what you're saying. I don't know that I fully have earned the right to that. To some degree, I sometimes think I'm a pretty stubborn person. So I think that maybe there's some areas that is easier and some areas that are hard. I think it's also worth really acknowledging my own unearned privilege here. Like I'm a straight white male. I very rarely have someone tell me that like question what I know or make me think that I'm not good enough. So I think that I'm not used to. I've had to learn like no one's telling me that what I'm right, what I'm saying is not right. So sometimes it has been a skill I had to learn that I need to question myself. If people are not questioning me enough, I'm not getting stronger. I've gotten to a place where I appreciate that I tend to do what's familiar, but not necessarily what's best. And sometimes what's best is what's familiar, but a lot of times it's not. And I really want to grow and get better. And I found that people give me a lot of grace for if I'm just honest in owning things I could do better next time. Because as much people want it to go well the first time, they really want it to eventually get to that place. So that's sort of the life I live. Is I'm trying to give myself grace, try to remember that parenting, I'm trying to remember that I made the same stupid mistakes myself and that, like I'm telling you, it's much easier to say what I'm saying than to actually live what I'm saying. So I hope you'll all
Yeah.
give me grace when you see me mess up. But just being silly, but being serious, it's something I've absolutely had to learn. I still, the more I see what I'm doing, the more I still think I'm not where I want to be, but I'm trying to get better every day.
Yeah, I feel that 100% in every area of life that I'm not where I want to be, but it is that constant pursuit of growth and evolving. And that kind of leads me to grassroots workshops because that is, I mean, I'll let you explain it, but I think that is a great like area or ecosystem to get involved in and just to experience that growth and learning new things about math and being an educator. So, can you tell me a little bit about why you started Grassroots Workshop and what it is?
Yeah, thank you. So, just simply put, Grassroots Workshops provides online workshops from education leaders that you know, like, and trust. So, I want you to think about your own professional development experience. We live in this weird hypocrisy where administrators tell us to differentiate for our students, but professional development is rarely differentiated for us. And so it's just like, learn this one skill from this one person that you might actually know more than, but learn this skill and now figure out how to make it work in your classroom. Oftentimes you have to learn around someone else's schedule. Maybe you're having to write sub plans. It's not when you want to learn. You don't have extended opportunities. Like, for example, sometimes it's nice to learn something, then go try it out, then come back and learn some more. And so a lot of the professional development options we've had traditionally don't meet these needs. So these are online workshops where you can learn over an extended period of time. There's probably a lot of people already on the website that you're a fan of. We're trying to grow our list and add new workshops all the time. But it's really just a different way of conceptualizing professional development centered around what the educator needs and not what is most convenient for delivering it.
Yeah, I love that. And you do have quite a few options on there. I was poking around and seeing like what you had available. You know, there's so many options for what to learn, areas to grow. I mean, even just myself as an educator, I could list like 12 different areas I'd love to learn more about. Do you have any recommendations for the teacher who's like, okay, I want to grow professionally, but I'm not really sure what to prioritize? I mean, do I focus on this area or do I focus on that area? Like, how do they go about even choosing where to start when it comes to their own professional development?
All right, three thoughts on that. The first one, again, is give yourself grace. The messaging is all around all the things you're not good enough at. And there's never enough time and never enough money. So just realize that whatever you're able to do and whichever version of yourself you're able to bring, that's good enough. So if now you're trying to think of all the things, like it's a little bit overwhelming, what am I going to pick? The first thing I'd recommend is there's actually a quiz that you can take that will help you, will ask you questions to help you narrow down from all the workshop topics to ones that might be better fits for you based on what your interests are. So that could be a really good, ask you questions about the timeline of what you want to take it and how deep you want to go and subjects you want to focus on. Virtually all of our instructors are on social media and have their own website, and you can go and kind of explore a little more about what they're sharing and get a feel for what their style is. But the workshops are pretty affordable. The mini workshops are $45 each, and you can get graduate credits for $62. So it's a really good way to move over the pay scale as well. But the opportunity cost, if you think about like going to a conference, those are wonderful experiences. I think it's still valuable to go. But if we're being real, I mean, that could easily cost, just 500 for registration, maybe 1,000 more for travel. That's a hard thing to do, especially if you're gone for a few days. So I think that this is a part of like a well balanced diet of professional development and not necessarily meant to replace everything else you're doing, but it could be nice to have once in a while.
Yeah, I definitely feel like that is a great option, especially the fact that it can be teachers can take it and they can use it and experience it in an on-demand, asynchronous type of setting. So I love that. I do like the fact that I like your recommendation to have teachers go follow the instructors online, see what they're doing. And earlier in our conversation, you talked about like growing by 10% and recognizing that yes, we may want to grow in all of these areas, but what is that 10% that you're excited about, that you want to learn more about and try that out? So something that I value a whole lot is growth. That is one of our core values here at Mix and Math. And so I thought I would leave you with this last question that I'd love to hear. You know, you have been a part of my growth journey as an educator. And so I would love to hear from you. Is there like an educator or a researcher or a conference or book that has really just had a huge impact in your growth journey as an educator?
Oh, wow, that's a good one. Okay, so I will have to say that right now, the thing that is most driving my own professional learning is Building Thinking Classrooms by Peter Liljedahl. Um, Prior to that, it was Five Practices for Orchestrating Mathematical Discussions by Mary Kaysen and Peg Smith. But Peter's book is the most game-changing book I think I've ever seen. I genuinely don't think there will be a more important book for math education in my lifetime. I mean, I have a blog post called "You Must Read Building Thinking Classrooms." It is the most important research for math education that I have seen in my lifetime. If you want to, I have a book. Get his book. Don't get my book. Like maybe get my book later, but definitely get his book. It's simply put, he researched everything. He took everything that we do in classrooms and broke it up into 14 categories and try to figure out, like, is this the best way to do it? I'll give you an example. Kids typically write while sitting down. What would happen if they stood up? Would it increase thinking? Would it decrease thinking? Would it have no effect? Like, how do you know? He didn't know, so he wanted to check it out. And he took all the different things, like, should they write horizontally? Should they write vertically? He tested all of that. And the crazy thing is that when I take all of the tips and put them together, I've never seen results and engagement like I see when I'm using them in the classroom. So I would say, if I'm being generous, I'm like a beginning intermediate at implementing them. And I really hope to get better at them because I've literally never seen anything have such a great ratio of small change to big result. So that would be what I would recommend.
Yeah, absolutely. We did our book study this past summer was on building thinking classrooms. The teachers that have gone in and they've implemented just even the first three practices are like, oh my goodness, it is a game changer. So his book is amazing. His work is wonderful. And I love hearing that, that's just had a profound impact on you because it has on me and the teachers in our community. So a fantastic book. Highly recommend it. All right. So I'm going to leave all of your Instagram and Twitter handles, or X, I guess people are calling it nowadays, all of that stuff. But where is like the number one in your website and books and all of that? But where is like the number one place that if teachers want to connect with you, that you would um, love me for me to send them to you there?
Yeah, these days, Instagram is where I'm at. I would love to connect with you there. And definitely, I really want to connect with teachers who are passionate about math education and education in general. So that's where you can find me.
Awesome. Well, thank you so much for joining me today. It was like a pleasure talking to you, and I cannot wait to talk math with you again soon.
Awesome. Thank you, Brittany.